In this video today I have to discuss about the reduction form, like the formula of In, where n is the positive integer, and also In was 0 to 90 sin x to the power n dx, and whose power is more than 1 and it being a positive integer. Okay, see here the solution for In whose degree is n, where n being the positive integer. See here, this is In and it is 0 to pi by 4 tan x to the power n and dx. I have taken Jn without limit tan x to the power n and dx. It will be written as, this is no limit, tan to the power n minus 2x and tan square x dx. Okay, again see Jn, and this is can be written as tan x to the power n minus 2 tan square x, that would be sec square x minus 1 and dx. Actually that's why we taken as a power of 2, and it can be expressed as a sec square x minus 1, and you know the derivative of sec square is tan x, so that's why we can break the disease as n minus degree as n minus 2 and tan square, and we have separation by tan to the power n minus 2 x and sec square x dx, and again minus, that is tan x to the power n minus 2 dx, n minus 2x and dx. Okay, we can easily write here n minus 2x sec square dx, dr we can write tan x. Okay, as the derivative of tan x is sec square x, and here is without no respect to, that's why it is dx here. Okay, and this is written as the notation Jn, then degree be n. If the degree n minus 1, then suffix be Jn minus 1. Okay, and see here this is n minus 2, so we multiply by Jn minus 2 there. Okay, and the z to the power n minus 2 and dz, x to the power n minus 2 dx, that would be written as tan x to the power n minus 2 plus 1 by n minus 1 minus jn minus 2. Okay, so this is equal to tan x to the power n minus 1 by n minus 1 minus jn n minus 2. This is jn. Okay, now see the limit here is, this is a form, okay, reduction form ruler for the tan inverse x without limit. If we put limit, like this is In, then tan x to the power n minus 1 by n minus 1, and limit is pi by 4, and jn minus 2 it transferred to I suffix n minus 2 here. Okay, and this is equal to, we put pi by 4, that is n minus 1 minus 0. Okay, and this combination is in minus 2 is equal to n minus 1 here. Okay, and this is the form, and another formula is, if we put here is n plus 1, n plus 1, then replacing n plus 1 in place of n, then the form is like n plus 1. Okay, I n plus 1, that is I n minus 1. N plus 1, that is 1 by n. And this is the formation. Okay. And use this form, we have to find the value of I6. This is your queries here. Okay. Now you see here, this is the reduction form. Okay. See. I6 means, that is the formula, In equal to 1 by n minus 1 minus I n minus 2. Use this formula of this. Okay. 1 by 6 minus 1 and I4, that is minus 1 by 5 only. I4 means, again we write 1 by 4 minus 1, and this is 4 minus 1 means 2. Okay, again write 1 by 5 minus 1 by 3 plus I2 here. Okay, and that will be 1 by 5 minus 1 by 3 I2. I2 means, this is here 2. 2 minus 1, 2 minus 2. That is 1 by 2 minus 1 minus I suffix I naught. So taken LCM, that is 15. 3 minus, this is minus 2. Last one, and I naught. If this is I naught, then degree is 0. So that's why 0 to pi by 4 and tan x to the power degree is 0, and this is dx. So this is equal to 15 minus 3, 13 by 15. 13 by 15 and only dx. This is 0, means due to this one, dx means pi by 4. That is your answer. Okay. And again, now see the solution for 0 to pi by 2 sin x to the power n dx. And now for in 0 to pi by 2 sin x to the power n and dx. It can be also expressed as like 0 to pi by 2 sin to the power n pi by 2 minus x and dx, and this is transferred to pi by 2 cos x to the power n dx. Okay. See here, in the case of tan, whose degree is n, and then we have to use the degree like n minus 3 into tan square x, as we want to get the sec square. But here is sin x, we have to use the formula of IVP, integration by parts. And now I have taken Jn without limit, that is okay, like that. For use of IVP integration by parts. Okay, this is the relation in. So here use sin x to the power n minus 1 sin x dx and dx of sin x to the power n minus 1 sin x dx, and this is dx. Integration of sin x, this is minus cos x. Same as differentiation of that, okay, n minus 2 and sin x to the power n minus 2 Okay, differentiate, this is n minus 1 and this is n minus 2 and dx of sin x is cos x. Again, integration of sin x is minus cos x and dx. See, cos x sin x to the power n minus 1, this is minus minus plus, and this is minus plus n minus 1. See here, sin x to the power n minus 2, and if you put a cos or cos, that is cos square. So cos square can be written as 1 minus sin square dx, as this is the sin x. So again, cos x minus sin x to the power n minus 1 plus n minus 1 sin x to the power n minus 2 dx, and this is sin x to the power n and dx. See here, this is n, then degree bn. So you got the same figure. So that's why Jn is equal to minus cos x into sin x to the power n minus 1 plus n minus 1, and these also can be noted like Jn minus 2 here, and this is Jn. Okay, these will be multiplied by this part, so this is the coefficient will be n minus 1 also here. So this is here n minus 1 into Jn, and Jn transfer to the left hand side, then Njn minus cos x sin x to the power n minus 1 plus n minus 1 Jn minus 2 divided by n. So this is the without limit reduction from is this here. This is n minus 1 by n and Jn minus 2 here also. Okay, without limit. If we use the limit, if we use the limit here, so we have to write here. I think this is the portion I have to write here. In, I'm into in here. This is J. In we written that, but it means we have to use the limit 0 to pi by 2, and that is equal to, we have to use this in this part, minus cos x and sin x to the power n minus 1 by n, and this is 0 to pi by 2 plus n minus 1 by n, this also in minus 2. Okay, implies that in is equal to, we have put the value, that is pi by 2, cos or sin, cos value is 0, sin is 1, therefore is 0, and lower limit is 0. That's why it is 0 always. N minus 1 by n, this is n minus 2 here. So in equal to n minus 1 by n into in minus 2. Okay, this is the reduction formula for in equal to 0 to pi by 2 sin x to the power n dx, or cos x to the power n dx also here. And also it would be, can be find easily I7. So see, okay, see here, I is n, that will be n minus 1 by n and n minus 2. Find I7, 7. So that is 7 minus 1 by 7, I5. Okay, that is 6 by 7. Again I5. Then use the formula 5. 5 minus 1 by 5, and this is 3. So 5 minus 1, that is 4, and by 5, and 5 minus 2, that is 3 again. Again 6 into 4 by 7 into 5, I3. 3 minus 1 by 3, that is 2 by 3 into 3 minus 1, 3 minus 2 is 1. And that is equal to 6 into 4 into 2 by 7 into 5 into 3, I1. I1 means 0 to pi by 2, this is 1, sin x and dx. 6 into 4 into 2 by 7 into 5 into 3, and the integration of sin x, that is minus cos x, and 0 to pi by 2. So 6 into 4 into 2 by 7 into 5 into 3, and that will be 0 minus plus, this is 1. Okay, this is our answer. Okay, and also reduce the another form of this part. See here. See here. Reduction from in, that is n minus 1 by n, in minus 2. So in this form, in this reduction form, we have to use the n is an integer here. So there are the two types of formation for odd or even. Okay. See here, find this. Replace n minus 2, that is n minus 2 and n minus 2. So n minus 3 by n minus 2. Okay. Again, see here, if we put that is I, n minus to find n minus 2, n minus 4 here. Okay. So n minus 1, n minus 3 by n minus 2. Again, find that n minus 4, n minus 4, n minus 5, n minus 4. So n minus 5 by n minus 4. And here is n minus 6. So this formation goes to the for the ending point like 2, 3. So we have now taken when n is an even number. When n is an even, then what happened? N minus 1 by n minus 3 by n minus 2, n minus 5 by n minus 4. Okay. For this formation, so last even number for this extension we see here, that is 2. That is 2. So we have put 2 here, then we got here I suffix 0. We have put there 2, then we got 1 by 2 here. Okay. Then after that, the ending even number be 2 here, then the preceding number when is an even, that will be 4. If we put 4, then 3 by 4. So previous number 3 by 4 here. Okay. And this is I naught. How can find it? Very easily. 3 by 4, 1 by 2, I naught. If not, then degree is 0. Sin, that is 0 to pi by 2, sin x to the power 0, and this is dx. So n minus 1, n minus 3, this is 3 dot 1 by n minus 2 dot 4 dot 2, and this is dx only, that is pi by 2. Okay, when n is an even number. Okay, and now in is equal to same as n minus 1, n minus 3, okay, n minus 2 here. Same as for this figure, the last odd number be 3. Okay, then you got 3 here. 3, if you put 3, then this is I got I1. If 3 minus 1 is 2, 3 minus 1 is 2, and this is 3. Okay. Again, the previous odd number for what for the sequence is 5. If we put 5, then 5 minus 1, this is 4, and this is 5 here. Okay. ঠিক আছে, and this is n minus 1, n minus 3 dot 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 by n minus 2 that is 4 dot 2 and 5 into 3. This is I1. So I1 is 0 to pi by 2 sin x, and this is dx, and integration is minus cos x, and limit is pi by 2. This is pi by 2, and this is 1, and this is 1. Okay, so this is the formation for reduction formula. Okay, bye in this class.